Justin from the National Hurricane Center, as Tropical Storm Melissa formed shortly before 11 o'clock Eastern this morning. You see the post on your screen there from Phil Klotzbach. Phil saying that this is the first tropical system to form in the Caribbean this season. He's a researcher at Colorado State University. It is a complicated future for Melissa, as there are several scenarios and paths this storm may take over the next few days, which we'll dig into coming up later in the hour.
The Caribbean is bracing for what forecasters are calling one of the most unpredictable storms in recent memory, as Tropical Storm Melissa threatens to unleash devastating rainfall across multiple island nations over the coming week.
Eastern this morning. You see the post on your screen there from Phil Klotzbach. Phil saying that this is the first tropical system to form in the Caribbean this season. He's a researcher at Colorado State University. It is a complicated future for Melissa, as there are several scenarios and paths this storm may take over the next few days, which we'll dig into coming up later in the hour. But Phil Klotzbach joins us now. He's that hurricane specialist and senior research scientist. Phil, good to see you. Thanks for joining us. And what great timing, right? We just had tropical storm.
The Caribbean basin witnessed the development of its initial named weather system when Melissa achieved tropical storm classification around mid-morning hours. According to analysis from Phil Klotzbach, a meteorological investigator at Colorado State University, this marks an unprecedented delay, as the region last experienced such a lengthy period without cyclonic activity in 1997. The delayed emergence of Caribbean cyclones during this Atlantic hurricane period presents an intriguing meteorological puzzle. Several factors make this delay particularly surprising to atmospheric scientists. Ocean temperatures throughout the basin have remained exceptionally elevated, while atmospheric conditions that typically disrupt storm development, specifically vertical wind shear, have stayed relatively calm for most of the season. Near neutral to cooler oceanic patterns across the Pacific have prevailed, conditions that historically diminish destructive wind patterns aloft.
For Melissa, as there are several scenarios and paths this storm may take over the next few days, which we'll dig into coming up later in the hour. But Phil Klotzbach joins us now. He's that hurricane specialist and senior research scientist. Phil, good to see you. Thanks for joining us. And what great timing, right? We just had Tropical Storm Melissa form. You always have a unique stat, and you had mentioned in that post on X that the last time
when these cooler Pacific conditions exist, they generally reduce the intensity of upper-level winds that can tear developing storms apart. These favorable ingredients should have spawned multiple systems months ago, yet the Caribbean remained remarkably quiet until now. The water beneath Melissa currently measures between 85 and 87 degrees Fahrenheit, providing abundant energy for potential intensification. Surface warmth alone offers tremendous fuel for any developing disturbance. However, moderate atmospheric resistance from changing winds at different altitudes may limit how powerful the system becomes over the coming days. The presence of wind shear, that variation in wind velocity and bearing across different atmospheric layers, could constrain development
activity in the Caribbean. A couple of reasons. One is that, we have had cool, neutral, and so basically not quite to La Nina, but on the colder side of normal. Most of the season now, no officially declared La Nina present. When you have La Nina, that tends to reduce levels of vertical wind shear, which is that change in wind speed and direction with height in the atmosphere. Too much shear tears apart hurricanes, and in general, the shears.
Excessive amounts of such shear can literally rip apart hurricanes and tropical storms as they try to organize. Throughout most of this season, these disruptive forces have remained relatively subdued across the Caribbean region, which paradoxically makes the lack of earlier storm formation even more puzzling to researchers. The storm's formation location in the western Atlantic basin fits typical late-season development patterns. During the early and middle portions of hurricane season, particularly around the peak months, numerous systems can emerge directly from African shores, spawned by robust thunderstorm clusters known as easterly waves. As autumn advances, these atmospheric disturbances continue serving as fundamental building blocks for cyclones, though they typically don't coalesce into organized systems until progressing much farther across the ocean. The position where Melissa came together represents a classic location for October storm genesis.
That tends to reduce levels of vertical wind shear, which is that change in wind speed and direction with height in the atmosphere. Too much shear tears apart hurricanes. And in general, the shear has actually been fairly low in the Caribbean for most of the hurricane season. And also right now the Caribbean is extremely warm, so there is, plenty of fuel for Melissa. So we would have expected to have seen more activity in the Caribbean this year, but unfortunately Melissa, given its likely kind of slow-moving track, is probably going to be, pretty.
What previously held this particular disturbance back involved too much vertical wind shear across the eastern and central Atlantic regions. As one moves westward later in the season, however, these disruptive atmospheric forces diminish to levels that permit tropical development. The Caribbean maintains extraordinary warmth every October, though this particular year has seen temperatures climb even beyond typical seasonal norms. Melissa will traverse areas where ocean thermal readings remain in the mid to upper 80 seconds Fahrenheit throughout its projected path. Water temperature certainly won't limit this system's growth potential. The minimum threshold for tropical cyclone formation generally hovers around 78 to 80 degrees, making current conditions exceptionally conducive.
It's actually been fairly low in the Caribbean for most of the hurricane season. And also right now the Caribbean is extremely warm, so there is, plenty of fuel for Melissa. So we would have expected to have seen more activity in the Caribbean this year, but unfortunately Melissa, given its likely kind of slow-moving track, is probably going to be, pretty bad storm in that region, just given there's a lot of land masses, there's not a lot of places it can go where it's not going to cause at least a lot of flooding.
Instead, vertical wind shear will likely determine ultimate intensity, with predictions suggesting moderate levels, possibly trending somewhat stronger than moderate, persisting over the next several days. Forecasters face considerable challenges predicting Melissa's future behavior, a situation that has generated substantial discussion among meteorological professionals. While confidence typically increases once naming occurs, significant questions persist regarding this particular system. High-pressure systems positioned both northwest and northeast of the disturbance create a gap that could trap the storm, causing it to meander with minimal forward motion through the weekend. The strength of the subtropical ridge, that semi-permanent high-pressure area, becomes absolutely critical in determining steering currents. 2. Distinct high-pressure zones essentially bracket the system, with a weakness developing between them.
So we would have expected to have seen more activity in the Caribbean this year, but unfortunately Melissa, given its likely kind of slow-moving track, is probably going to be, pretty bad storm in that region, just given there's a lot of land masses, there's not a lot of places it can go where it's not going to cause at least a lot of flooding. And obviously we'll see about wind. It just depends on the exact track, as Brian was talking about a few minutes ago, as to how much time it spends over water, exactly where it goes. Obviously if it interacts a lot with land, maybe.
This configuration often produces a recipe for stalling or extremely sluggish movement. Such stalling patterns aren't unusual during any month of hurricane season. Storms can and do slow down or become nearly stationary at various times throughout the year. What makes this particular scenario noteworthy involves October's typical characteristics and what happens when forward motion grinds to a crawl in the Caribbean specifically. When tropical systems move very slowly, they typically weaken themselves through a process involving ocean dynamics. The powerful rotating winds mix and churn the water, bringing cooler subsurface water upward toward the surface.
Moving track is probably going to be, pretty bad storm in that region, just given there's a lot of land masses, there's not a lot of places it can go where it's not going to cause at least a lot of flooding. And obviously we'll see about wind. It just depends on the exact track, as Brian was talking about a few minutes ago, as to how much time it spends over water, exactly where it goes. Obviously if it interacts a lot with land, maybe it won't be as strong, but it'll just have even potentially more flooding impacts.
How about the origins of
this process, called upwelling, essentially robs the storm of its primary fuel source, leading to weakening. The Caribbean presents unique thermal characteristics that alter this typical pattern. Unlike other ocean areas where sluggish movement allows storms to churn up cooler subsurface water and weaken themselves, the Caribbean maintains extraordinary warmth extending far below the surface. The heat content doesn't just exist at the ocean's skin, it penetrates deep into the water column. When powerful winds circulate and mix the water, they simply bring additional warm water upward from below. This allows systems to maintain or potentially increase strength despite minimal movement, a feature that makes slow-moving Caribbean storms particularly concerning.
The Cabo Verde season tends to wrap up. Would you consider this season to be a bit anomalous when we look at this late season wave which emerged off the coast of Africa and now is named Melissa?
I mean, so typically early and middle of the season, especially middle of the season, you can get a lot of storms forming right off of Africa from what we call these easterly waves. So these strong thunderstorm complexes. As you get later in the season, those waves will still serve effectively as seeds for tropical storms and hurricanes. They just don't form until they get farther west in the basin. So kind of where Melissa has formed.
The region has remained largely untouched this season, contrasting sharply with recent years when multiple powerful systems ravaged these waters. Multiple land masses throughout the region face threats regardless of Melissa's exact route. Limited open water corridors mean almost any trajectory will bring impacts to populated areas. The geography simply doesn't provide many escape routes where the storm could travel without affecting communities. Flooding concerns dominate the threat assessment, particularly given the likelihood of slow movement, allowing persistent, heavy rainfall to accumulate over the same locations for extended periods.
It's kind of a classic location for storms forming in October. Typically, and what kind of held this storm back as well, is there's too much vertical wind shear in the eastern and central Atlantic. As you get later on in the season, but as you go farther west, the shear is low enough that you can support storms. Certainly the Caribbean this time of year, every year is extremely warm. This year even warmer than normal. Most of where Melissa is going to track water temperatures are 85, 86, 87 degrees Fahrenheit. So certainly
wind damage potential depends entirely on how much time the system spends over water versus interacting with terrain. Land interaction could either limit strengthening or, conversely, increase precipitation-related hazards even as wind speeds potentially decrease. Official forecasts indicate Melissa will likely achieve hurricane classification. The explicit prediction calls for Tropical Storm Melissa to intensify into hurricane-strength winds, though considerable uncertainty remains about timing and ultimate peak intensity. Model guidance generally agrees the system will move very slowly, though exactly how slowly remains somewhat unclear. The rate of movement will prove crucial for determining local impacts, as a nearly stationary storm produces vastly different effects than one maintaining even modest forward progress. As the 13th named system with approximately 40 days remaining in the annual season, Melissa refocuses attention on a basin that has remained remarkably undisturbed compared to recent years. The contrast with previous seasons couldn't be starker. Just 1 year earlier, the Caribbean experienced significantly more activity, with systems like Beryl demonstrating the region's capacity for rapid intensification when atmospheric and oceanic conditions align favorably. This current storm doesn't compare to that previous powerful hurricane, yet the potential clearly exists given the available energy in the system and ocean. Looking beyond this immediate threat, November typically brings sharply reduced probabilities for United States hurricane impacts. Historical records provide some comfort, showing only 4 November landfalls affecting American shores throughout recorded history. The odds genuinely decline dramatically as autumn progresses into its final weeks. However, recent exceptions prove that late-season activity can still produce significant impacts. Hurricane Nicole slammed into Florida as a Category 1 system in early November 2022, while Hurricane Zeta crashed into Louisiana as a Category 3 inches late October 2020, demonstrating that late-season storms can still pack considerable punch. For those monitoring with particular interest in United States impacts, the forecast challenge extends well beyond the standard 5-day window that the National Hurricane Center provides for intensity predictions. Considerable time remains to observe this evolving situation, with hope that the system will simply slow down without achieving hurricane strength. Yet the Caribbean's exceptional warmth this time of year demands continued vigilance and attention. The positioning of atmospheric pressure in systems over the next week will ultimately determine where Melissa travels and how long it persists over vulnerable Caribbean territories. Those high and low pressure areas will prove critical in dictating the storm's ultimate track over the coming week or more. Forecasters can project intensity changes only through 5 days currently, leaving considerable time for this evolving situation to develop in unexpected ways. The forecasting challenge encompasses not just where the system will travel, but how strong it will become and when various atmospheric features will interact with it. Each of these factors carries significant uncertainty that compounds when looking beyond the immediate forecast period. As atmospheric patterns shift and the system continues organizing, clearer pictures should emerge regarding ultimate impacts and affected locations. Tropical Storm Melissa has officially formed in the Central Caribbean Sea as of Tuesday, the 21st of October, 2025. The National Hurricane Center confirms maximum sustained winds have reached 50 miles per hour, with the system located approximately 300 miles south of Port-au-Prince, Haiti. Current movement remains westward at 14 miles per hour, though significant deceleration is anticipated within 24 hours as steering currents collapse. A hurricane watch has been issued for Haiti's southern peninsula from the Dominican Republic border, Port-au-Prince. Jamaica has issued a tropical storm watch for the entire island. Forecasters project Melissa will achieve Category 1 hurricane status by Saturday morning as it drifts over Caribbean waters, measuring in the upper 80 Secunda Fahrenheit. Two primary forecast scenarios dominate current model guidance. The more probable track shows rapid organization with a northward turn toward Hispaniola by Friday, bringing catastrophic rainfall totals of 12 to 30 inches across Haiti and the Dominican Republic through the weekend. Extreme flooding and deadly mudslides represent the primary threats for mountainous regions. The alternative scenario involves slower intensification with continued westward drift for several days before potentially turning toward Cuba or Central America early next week. Puerto Rico faces indirect impacts from tropical moisture bands, even if Melissa's center remains far to the west, with flash flooding concerns elevated across the island. Direct mainland United States impacts remain unlikely based on current atmospheric patterns, though South Florida residents should continue monitoring developments. Strong westerly jet stream winds should prevent northward movement into Gulf of Mexico regions. Substantial uncertainty persists regarding both intensity and precise trajectory, particularly concerning when Melissa will execute its anticipated northward turn. The Caribbean's unusually deep warm water layer means traditional weakening from slow movement may not occur, potentially allowing continued strengthening despite minimal forward speed. All residents throughout the northern Caribbean should complete protective preparations by Thursday as conditions deteriorate rapidly.